Hello everyone, welcome to the TD tutorial of our class. In this class, I will take you to do the interactive project with a sense of humanity that I just showed you. So in this project, we can see what we can achieve is that such a small ball changes with the change of our whole body. I don't know if you have seen a very popular case on Little Red Book before, which was done by a studio in Korea. They achieve their effects through game engines such as Unity and UE. So, we can also achieve similar effects in TouchDesigner. Alright then, let's get started. First of all, let's open it. If you don't have Kinect, you can open an ZEF file. In fact, we have talked about it in our previous tutorial. How do we implement a debug on Kinect data without a Kinect? So we use this kind of ZEF file. This is a pre-recorded file of a dataset to achieve such an effect. After we opened it, we connected it directly first. Then, remember to change the loop count to a very large number, just 1000, and then let's play it. So well that our entire Kinect data will be played in the background here. Okay, let's open TD. Let's delete all of this and turn it off. Then, let's create a Kinect chop first. We see the Kinect Studio running in the background, and the data it shows has been played here in real time. This is a data I recorded before. Okay, first of all, we need to convert this data into a point cloud. Let's create a select later. Then we add a TX after the channel names. What does that mean? In this case, we extract all the TX values of all the data. Well, let's extract TI and TZ in the same way. Okay, let's extract TI and TZ in the same way. We'll change the second one to TI and the third one to TZ. This way, we can directly extract the TX, TI, and TZ datasets from our data. Then we use shuffle to sort it again. Then we changed the shuffle method to sequence all channels. In that case, we have changed it to single channel data. Similarly, we can directly copy and paste them to connect them. Okay, then we merge these three data together. Finally, a null comes out. What is this? Equivalent to our entire P1, he has all the data such as TX, TI, and TZ on him. Okay, and then we go through a top to component and convert it into a point cloud. We also need to change the data a date format to RGB so that we can see that it has 25 points. There are 25 pixels in total, which corresponds to 25 points. Then we can click on the viewer active in the bottom right corner, and then press V or right-click here. And then what can we see? Here we have transformed the data points of all the key parts of the body that our body can detect in the form of such a point. We add a fit. Then we change the pixels here in fit to a 25 by 1, which is equivalent to the same as before or the same as it. Why is that? Because sometimes, if our computer configuration is not sufficient, there will be some bugs in the entire conversion process, and it will constantly jump the size of this data here. This will cause a lot of stuttering in the back of us. We use this fit to lock the entire pixel to 25 pixels. Then there will be no so-called data jump as mentioned just now. We'll add another null after it. Then we go to render it to see the effect. Let's create our rendering set of 4. Create the sphere first, and then we lower one of its subdivision surfaces, change it to 4 by 4, which is too low, and change it to 10 by 10. Okay, then add transform after it. Turn it down a little. Adjust a 0.1. Then connect another geo to the back, followed by the camera. And then light. Render. Then we add a null at the end and we render it. Okay, then let's follow what we learned before and use the instance function in geo to open the instance. Change the name of null2 to POS, and this is our location information. We put the POS on the translate op. Then there are 3 values corresponding to RGB. We also see that our whole body data has been completely mapped on the ball. It looks a little big now. We can get through here. Let's move it out a little more. We add a point transform here in the middle to adjust its position. First of all, let's narrow it down a little. That's it. Then we can reduce the uniform scale of the small ball to this small size, which is almost the same. We have now realized that each point corresponding to a small ball, every joint on our body corresponds to the form of such a small ball. What is the situation we see in our case? Yes, the whole body is full of small balls of various sizes and colors. The first thing is to fill the picture with this little ball. Is that every joint in the body is filled with small balls. The second thing is to make these balls of random size. The third thing is a random color. You should have learned the last 2 things. The students in the previous course should be quite clear. Just adjust it directly through the scale and color parameters in the instance in Geo. So the first one is how do we expand the number of small balls on it. This project is a case study from lesson of the GemSeed Touchdesigner course. In the course, we provide an in-depth breakdown of the implementation principles behind this effect, along with additional creative interaction methods. But that's not all. The GemSeed Touchdesigner course offers 20+ hours of content, continuously updated, 40+ TOE and TOX learning files, integration with Kinect, Leap Motion, and other interactive devices. Ready to level up your touch designer skills? Get the course link in the description and comments. If you have any questions about Touch Designer, you can join my Discord to ask me questions and I will do my best to answer them all.